Okay. So what we were discussing is statistics. Statistics is all about what? Statistics is all about, or it's a study of like collection of data, then analyzing the data, and third step can be presentation of data, and then interpretation. Okay,
Okay.
that is all about statistics. Now today what we are going to do, why am I speaking about all these things? Today we are going to look into presentation of data. Okay, we are going to see how to present a data, or how the data is presented in graphical way, or in some other way. Okay, so let us see. First thing today, what we are going to discuss is interpret frequency. See, frequency is what, how often something occurs, or how often something happens. Fine.
Mm-hmm.
Okay. Abhijit, can you give me a second? Just a second. Just a second. Okay. So how frequently something occurs? So that is frequency. Suppose if I say there is a class of 100 students, there may be some instance whereby 10 marks may be scored by 5 students. It can happen, correct? So how
Yeah.
frequently 10 marks are scored? 5 times. Am I right? So that
Oh.
is frequency. And also we are going to see related distributions, how like the data is distributed. So a frequency distribution, see, already I have discussed with you what is distribution, but that was probability distribution. This is frequency distribution. So we'll take the data and we'll see how frequently we'll put the data in an interval. For example, I have already given you the example, like suppose there are like 100 students, okay, and the 100 students exam has been conducted for those 100 students, and the paper was of 100 marks. Okay, and what we can do here, we can take the data like in the first column. Okay, we can say that as observations, or observations I'm taking in the form of intervals. Okay, what is interval? I'll tell you, I'll explain you what is an interval right now. So I'll take that in the intervals of 10. Okay, so 0 to 10, 10 to 20, 20 to 30. I'm just showing you a frequency distribution. So this is a observation in form of intervals, class intervals. And then I'll see marks. That is marks. Then I'll see students. So 0 to 10, how many students have scored 5? That means 5 students like were those students who scored marks between 0 to 10. So how frequently this particular phenomena has occurred? 5 times. So there are some 10 students who come in this category. That means 10 times when the marks were distributed, okay, those were distribute the marks, or the paper or the answer sheet was given. It was given to such students who were in this category. Am I right?
Yes.
That means there were 10 students, 10 different students to whom 10 sheets were distributed, and those sheets had marks between 10 to 20. So can I say that is frequency? Yes. And when I
Yes.
show the data in this way, it is frequency distribution. So a frequency distribution is a tabular presentation of statistical data that aids the analysis of large data sets. And I already told you, when you have a very large data, you always have to go with the frequency, correct? For small data, you need not go for frequency. As I said to you, there are 5 students and they scored some marks. You can like take the data and you can find out the average. But if the data is a large one, there you have to make a frequency distribution and then you can find out the average or the mean, median, whatever it can be. Okay, that in the later part we're going to discuss now. So what they have done here is they have explained us frequency distribution summarize statistical data by assigning them to specified groups or intervals, which I did it here for you. That was the example. So first, we will not go for all these steps because we can directly and practically do the question here and understand. So, but we will remember the steps. So what is the step you have to follow when you construct a frequency distribution? First, you have to define the interval, correct? And then second, tally the observations. And then third, count the observations. And to follow the steps, what is the first step, Abhijit?
First, you have to define the intervals, no?
Yeah, first step is what? The first step is nothing but define the interval. So we'll do that first. Then tally the observation. So first step is interval, define that. Second step is to tally. Okay. Third step is to count the observations. Okay. Let's see. Let's do that here. Now, constructing a frequency distribution. So use the data in table A to construct a frequency distribution for the returns on Intelco's common stock. So Intelco Inc. is a company and Intelco Inc. company's common stocks annual returns have been given here. The data doesn't seem to be an organized one, but we will organize it. We will organize it. Okay. It's a random data. First, we will define the interval.
Okay.
Yeah. So first we will define the interval. For that, we'll see the range. Okay. What is range? First of all, range is largest value minus smallest value. Okay. So in this, what is the smallest value, Abhijit?
It looks like minus 28.
Let's say minus 28.6.
Yeah.
And the largest value is
40.
40.4. So 40.4% minus of minus 28.6. Can you calculate and tell me what is that?
1 second. 40.4 plus 28.6, 69. It's 69, sir. I just added the
69.
Yeah.
Now, next. After finding out the interval, see what you see here is using a interval of 1%. See, now if you take 1% would result in 69 separate intervals. So it doesn't make sense. So what we'll do is we'll try to put a range, okay, or a width of 10%. What we'll do? We'll try to put a width of 10% between the lower and the higher data in the interval, or we'll try to put we'll try to arrange this data in an interval form. Okay, we'll try to arrange this data in a interval form. So how we can do that? How we can make this data in an interval form? So we'll try to take the width of 10% and we'll see what is the lowest written here. The lowest written here is
minus 26.
We have already seen that the lowest into is minus 28.6 and the highest is this. So we can take some range of minus 30% to minus 20%. Can we do that?
Yes.
So we will go in that way. So we have taken minus 20, minus 30, the smaller one, and minus 20, the bigger one, and minus 20, minus 10, minus 10, 0, 0, 10, and like that we have brought it to 40 to 50. Okay. And now we'll see what data lies between this interval. So minus 32 minus 20, I think only minus 28.6 lies, correct?
Hmm.
So that they have put 1. And then we can do the next one, minus 22 minus 10. How many observations lie? Minus 22 minus 10, minus 12.4 lies. And then minus 17.6. Only two data would lie in this. Okay. Only two there are two kind of returns which is between this. So in this way they have done minus 10 to 0. How much of the returns would lie in that? Minus 10 to 0. See, minus 10 to 0, in the sense we are into the negative to 0. So what can you take in that? You can take minus 5.2, you can take minus 4.2, you can take minus 1.0, correct? Three
Yes.
of the returns. Yeah. In the same way, we'll take 0 to 10, and they are showing some 1, 2, 3, 4, 5, 6, 7, and 10 to 20 they are showing 3. This can be exercise which you can do from your text. So in this way we see all the we see how much frequently something has occurred in this interval. So 1 time, 2 times, 3 times. So then we say these as frequencies, correct? And the
Hmm.
total of the frequency is 20, and the one we see the highest frequency is in this interval. We call this as model class. What we call? That is
Model.
mode, isn't it? So
Yeah.
the highest frequency depicts mode. That's it. That is model interval. Now, relative frequency. See, you can also do this particular exercise with this relative frequency concept. Right now, we have only taken absolute frequency. What we have done?
Absolute frequency.
Yeah, so this was the absolute frequency thing. Now we are going to do the relative frequency thing. So how are we going to do in that case? You can see here the data is given, and you can do one thing. You can see how much percentage this frequency is in the total frequency, and you can make that in percentage form. Okay, so this 1 in 20 is 5%, 2 in 20 is 10%, 3 in 20 is 15%, 7 in 20 is 35%. In that way they have made it 100%. This is called relative frequency. What is this called? Because you are kind of relating these two, am I right? And you're trying to
Yes.
find the percentage. That's what. Now it is also possible to compute the cumulative absolute frequency and cumulative relative frequency by summing. See, cumulative is nothing but you can add up the things. Okay. So let's say they have taken returns less than 10. So returns less than 10 in the sense, if I'm not wrong, they are speaking about this data, correct? So
Hmm.
you add up all this, you get the cumulative frequency, you add up all this cumulative absolute frequency, and you get cumulative relative frequency. And they have shown that here. Correct, Abhijit?
Yeah, yeah. I
And
see
you
that.
can, what you can do is you can make a graph of that. Okay, so this is relative frequencies, and we'll see the percentages. Already we are speaking about what we are speaking about, the intervals here and the frequencies here. Okay, so the interval 0 minus 30 to minus 20, what is the frequency? 5%. That means 5% of the data lies in this interval, correct?
Huh.
10% of the data lies in this interval, 15% of the data lies in this interval. These were numerical values, these are percentage values. So what we'll do, we'll see that minus 30 to minus 20%, 5% of the returns lie in this, correct?
Yes, yeah.
That means data. And minus 20 to minus 10, 10%. And then minus 10 to 0, 15%. And it goes on 35%. Okay. This was about relative frequencies. Did you understand, Abhijit? Shall we go
Yes,
forward?
so far so good. Yeah.
Yeah. So I haven't done all this. Now we will see the contingency table. It's a two-dimensional array. So yesterday we were discussing about array. Array is nothing but if I take integers between 1 to 100 and put it in a proper in the sense I just put it in a proper I just store that data. That is array. Okay, isn't it? So if I store this data of 1 to 100 integers, it's an array. Fine, in a
Hmm.
proper sequence. Now, so now we'll see here some more kind of things, joint frequencies and marginal frequency and all. So we'll see a data here. What you can see here, there are two variables here, Abhijit. One variable is the days of a week. Am I right? These are the variables. And this shows the intersection. You know what is intersection? Like in we say that intersection is a, like, you know, there are two roads which are crossing each other.
Understood.
Yeah.
Understood.
And these are the intersections. These are another variables. Variables in the sense we are taking different intersections, different days of a week. And what does it show? This 5 shows accidents by intersection and day of week. That means there are two things this particular 5 would show you. That means there are two variables you are considering for concluding what this 5 mean. Okay. Can I say that is a joint frequency?
Okay. Yeah.
Yeah. We'll come to that. See, a contingency table is a two-dimensional array with which we can analyze two variables at the same time. The rows represent attributes of one variable and the columns represent attributes of other. So you can see the row here and the column. These attributes can be defined using nominal or ordinal data. Yesterday we have checked and seen what is nominal data and ordinal data in order, but there must be a finite number of them. So we have kept it like those are not something which are not countables. They are countables. Data in each cell show the frequency with which we observe two attributes simultaneously. These are called joint frequencies. So did I say the same thing? It's a joint frequency. Yes. So what does this phi mean? The phi means on Monday, in the intersection Palace Street, 5 accidents have occurred. Does it make sense?
Yes.
And on Monday, in all these 5 like intersections, total of 19 accidents have occurred. That's it. Finished. Now, we'll take confusion matrix now. 2 by 2 matrix. Yeah, the name itself is very clearly showing you that it's really something which is going to confuse you. So how we take this? See. So a confusion matrix for a model that predicted the outcomes of 1000 events. So there is some illustration here, figure 2.5, confusion matrix. It is showing confusion matrix for a model, okay, that predicted the outcomes of 1000 events. So here you can see total of 1000 events.
Okay.
Now we can read from this table that the model predicted the outcome would occur 662 times. So what is that? Prediction, yes. Okay. Okay. That 662 times the model will occur. Isn't it so?
Okay.
See, prediction is what you are forecasting, but in actuality,
So your voice is breaking up actually.
now can you hear my voice, Abhijit?
No, sir, not too well.
Now, hello, 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 Abhijit, can you hear my voice? Hello, hello.
Yes, sir. Yes, sir. Now it's audible.
Yeah, see, Abhijit, what does it show? See, figure 2.5 illustrates a confusion matrix for a model that predicted the outcomes of 1000 events. Okay. So there's a confusion matrix which is predicting. Okay, prediction is forecasting. Actuality, in actual, what happens is something which happens in actuality, but prediction is something which you are forecasting today. Okay. If the prediction matches with actual, that's a coincidence, but it won't happen much times. Okay. So we can read from this table that the model predicted, okay, the outcome would occur 662 times. So what did the model say? We predicted what? The model, what did we predict? Outcome would occur how many times? 662 times.
Oh.
So we predicted that the outcome would occur 662 times. But in actuality, it occurred how many times?
681.
681. Okay. In 28 occasions, we predicted that it would be happening, but the event, like on 28 occasions, the model predicted the event would occur, but it did not. Definitely correct. Actual, no. Am I right? While in 40 occasions, the model predicted the event would not occur when it actually did occur. So when we predicted that the model will not occur, but it occurred. Am I right?
Yes.
So 1000 events we are seeing here. 662 is the prediction what we made, but in actuality, how much times it occurred? 681. 28 times we predicted yes, but it did not happen. 47 times we predicted no, but it happened. So 681 times, correct? So did you understand this whole thing?
Yeah.
Okay. Shall we go forward or you want to read
Yeah.
once?
No, I'll have to read it once later so that I fully grasp it. Yeah.
No. Once you read, Abhijit, any doubts you ask me, please. I'm
Yeah.
giving
Yeah.
you time.
Yeah. I got it, sir. Yeah. Hello.
Yes, I'm going ahead. So Abhijit, you have to do this. See, I'm leaving these questions on you. These are some very simple ones. Explained all the concepts properly. Do this question. If you're not getting, if you want, we can discuss. What do you say?
Okay.
You want me to discuss or you want to go ahead
No,
with
I
the
want to do. I want to do it on my own, and we'll connect back.
okay. Now next one is the visualizing data. That is nothing but presenting the data in any ways with which easily it could be understood what the data wants to convey. Okay, so we will see first the histogram. See, every Tom, Dick and Harry and every guy who's been into these 10th standard knows what this histogram is, and we are going to make the histogram for Intelco's returns data. Okay, so let's see what are we going to do here. See, already you know the data fully, you know the absolute frequencies, and you know the range, okay, of the return would fall into. So from this minus 30 to minus 20, the returns, what we saw, how many we saw, how much time it was frequently repeating,
One time.
only one time. Why? Because only one of the observations lied between this interval, and that is here. And in this interval, two observations lied, and we see seven observations here. So this is a normal histogram which tells you about the occurrence of the returns in this particular range. Then we can construct a frequency polygon. Generally, when we used to make median related graphs, we used to make frequency polygon, correct?
Mm-hmm.
Long time back in school. Hope you remember or you don't, but we can again re-review this. To construct a frequency polygon, successive frequencies at the midpoints of the intervals are joined. So we will take the midpoints of the intervals. So midpoint of this minus 30 and minus 20 would be minus 25. So you find out the midpoints of all these, Abhijit,
Mm-hmm.
and you put it
That's
here, and then hello,
yeah. Understood, sir. Understood. Yeah.
and you exactly make the points and join the points with lines. Okay, then cumulative frequency distribution chart, I think I don't need to explain this already. It's very simple. Cumulative is always in this way. Okay, and it will become flat here, correct?
Mm-hmm. Yeah.
It cannot go beyond this range because the final thing is this, the 100%. So they have taken the percentage data and they have put it here, 5%. And then see, whenever I speak about cumulative, we take the previous value and the current value together. Okay, and 5 and second one was what, 10, correct? So
Mm-hmm.
it was what, 15 or 20?
Yes.
Just a second, let us see that view of the data. 5, 10, 15, 35. Okay. So 5, then it comes to 10, then comes to somewhere around like 15. So it will go in this way. Okay. And you'll see that graph will be made in this way. Correct.
Okay.
So it will take the previous data and the current data. That is cumulative. And here is a bar chart. So you see a bar chart, small data is given. The histogram shown earlier is an example of bar chart. In general, bar charts are used to illustrate relative sizes, degrees, or magnitudes. That means you can relate here. Na? mining and logging, construction, manufacturing, Bureau of Labor Statistics. So you see how many laborers are working in this, correct? We'll see employees on payrolls in goods producing industries Jan 20. Let us see the entire data here. We are making different bars here, vertical bars. So figure 2.9 shows a bar chart of employment in goods producing industry groups in the United States. From this chart, we can see that the construction industry employ about 10 times as many people as the mining and logging. That's right? Is it so?
Yeah.
Yeah, at least like tech, like in manufacturing, in what did they say? Construction. They said almost 10 times. Construction industries employ about 10 times as many people as mining and logging industries. Yeah, so here you see this is almost zero, almost like 8,000. So this is like almost 10 times. Am I right?
Yes, sir.
That's what they're saying. And like in manufacturing, it is bit less than manufacturing. Okay, manufacturing is even double than this construction one. Correct? Next.
Mm-hmm.
Then grouped bar chart or clustered bar chart. So that was the bar chart. Now we are doing grouped bar chart. We are taking the data of men and women employed in three segments of the US economy. Here we can see that more men than women are employed in the goods producing industries, but more women than men are employed in the service producing industries and government. We can see here. So in goods, see this is men, this is women, more men than women in the goods producing and more women than men in the private service producing and government. Fine. That is what
Okay.
is
Okay.
clustered bar chart or grouped bar chart. Now, another way to present two categories at once is with a stacked bar chart. In stacked bar chart, what you're going to do is you're going to take both the things, okay, men and women in goods producing. You see, men are like having more area in this, correct? Men have occupied more area and women have occupied this much area, small area. Here, woman is more and men is less, and here also woman is more and men is less. So that can be seen here, the change. But what are we doing in this? In a stacked bar chart, the height of each bar represents the cumulative frequency for a category. Cumulative frequency is nothing but you are taking the previous one and the current one and adding up those, correct?
Mm-hmm.
Such as the goods producing industries and the colors within each bar represent joint frequencies. So now I don't want to say anything more about this. Joint frequency is nothing but a table whereby you see like row and column confluence. The row and the columns confluence, you will be having some number here. That will be the joint frequency, correct? Example 5. Hello.
Yes, sir. Yes, sir.
Yeah, you understood this?
Mm-hmm.
Yeah, we did know that like all the intersections and the days of the week, and we saw this was a joint frequency, isn't it so?
Yes, yeah.
Yeah. So let's put this stacked bar chart into this. Just a second. So stacked bar chart, if I give you a small example, I'll just put a link here. But it's like it makes sense here. It's very easily understood. Now this is like
Yeah, understood.
some goods producing, private service producing and government. And what was the data here we had? We had men and women, and we saw in tens of thousands. Okay, the same data they are showing in stacked one. And what did they show? They did not give anything, but they gave thousands. Okay, and like how many women and men are working in that. So we saw 5,000 if women are working, and we saw 15,000 men are working here, correct, in the goods
Mm-hmm.
producing. So 15,000 is way ahead than 5,000. Same thing they have put it here in the stacked. So 15,000 men, it goes well, and 5,000 it goes well, correct?
Yeah.
This is 15,000, this is 5,000, same thing. Now tree map is another method for visualizing the relative sizes of categories. So we'll see the figure 2.12 is a tree map of labor force categories for United States by level of education. The filled areas of a tree map may each be divided into subcategories that are displayed in the different colors or shades. We'll see here. Tree map of labor force by educational attainment. So labor force, you know how they are educated, they'll be like posted. So high school graduates, like it's a small diagram here with different colors, but you know the colors are like very dark here and somewhat lighter. Okay, and this is even more lighter, and even this is very transparent kind of. It doesn't seem to be much more vibrant, like very light. Correct? We'll see it in that way. So you see high school graduates, no college, bachelor's degree. So high school is nothing but it's not a college, correct? So you see this much data in this, correct?
Yeah.
And they just given this statistics, but nothing they have shown like in thousands or whatever. So they just want to show the area occupied. Okay, they just want to show the
Area.
area occupied. So like much of the area here, we see the dark area of high school graduates who are not going to college, and then bachelor's degree. We see bachelor's degree and higher. We see somewhat lesser area. See, this is more broader one, correct? This is more broader. The width is more.
Mhm.
The width is less, correct? And here they have combined some school or associate degree less than a high school diploma. So very less people, somewhat lesser, somewhat somewhat more than this, somewhat more than this, and this is the highest, correct?
Yeah.
When analyzing text, useful visualization technique is a word cloud. See, this is word cloud. You see lot of words here, correct? And when you come to the like in between, it is mean, correct? The middlemost one, that is average, isn't it so? Hello.
Yes, sir.
Yeah, this is called word cloud. So when analyzing text, a useful visualization technique is a word cloud. A word cloud is generated by counting the uses of specific words in text data. So how much time some text has occurred in a data, they count it. Okay. It displays frequently occurring words in type sizes that are scaled to frequency of their use. So here you see which word is like much more times repeating. Come on, identify, Abhijit.
I think it will be the mean, yeah. Mean
It's
data.
very tough to analyze, but mean is the one which where can we see mean here?
So your voice is breaking. I think there's an internet issue.
Can you hear my voice now, Abhijit? Hello.
Sir, now I'm able to hear it, but there was a lot of disturbance.
Okay. Now can you see which like word is repeating much more times in this?
It's mean actually.
Mean, but where we see mean here, just in the center. Anywhere else?
No,
Then how come you can say that it is mean?
because it's a word cloud and the most number of times a word is repeated, that'll be the biggest one.
So from this word cloud, we can easily see two of the major concepts this topic review addresses: types of data and definitions of mean. Okay. So central frequencies, arithmetic model. So you see many a times here one more time average is used, correct? And median is like also a kind of average, and like wherever you see all the words, they are somewhere or the other related to or very much connected to mean. Am I right? Without mean, all these things cannot work. The standard deviation won't work. Okay. The kurtosis, no. Skewness, no. Correlation, no. For everything, what do you want? The highest number of usages for what? Which one would be which one will be used for all this? Either
Mean,
I
yeah.
take correlation, either I take skewness, either I speak about kurtosis, either I take any distribution. every time what I want. Correct.
Yeah.
And all this are very much for all this, whatever I want to find, I want what?
The mean, yeah.
No, mean. And as well as I want what? Data. And then I also want them to distribute in any ways. Okay. Now, so those are the ones which are the most times used with any kind of combination. Now we'll see about the line chart. So this is a line chart. Okay. What does it show? See, whenever you see the pulse rate, whenever you see the stocks returns, you generally see this line chart. Am I right? It shows
Yeah.
the increase or decrease, or like the peaks and troughs shows the fall or the rise in the stocks returns. Correct. So that is what the data shows. And then we have multiple time series. Can be displayed on line chart if their scales are comparable. It is also possible to display two time series in a line chart if their scales are different. So here they have seen dual scale line chart. What does it mean? Random time series company, made up data Inc. There are two companies. Okay. For those two companies, you are seeing the rise and fall of returns. Am I right?
Yeah. Yeah.
Or the stock prices, anything you can take. Then bubble line chart. This is the way the bubble line chart works. So you have made this bubble line chart, but what does this bubble line chart mean? See, another technique for adding a dimension to a line chart is to create bubble line chart. For example, hello Abhijit, can you follow me?
Yeah, so far. Yeah.
Yeah. In the figure 2.16, a line chart shows total revenues for a company, and at each point the different sized bubbles represent revenues per salesperson. Of course, now we can see here. We see the revenues to be the highest here in the year one, correct?
Yeah.
The size is the biggest, and here the lowest, and then again moderate. Then comes the scatter plot. Scatter plot is what actually you put there's a data here in the x-axis and y-axis, and accordingly you just make dots, and you see the more concentration of dots here, correct?
Yeah.
That means much of the data is lying in this area. The density of the data. And then here comes the heat map. So let us see what is this heat map is all about. A heat map uses color and shade to display data frequency. So figure 2.18 is something which shows the heat map. Okay, see, definitely these kind of things haven't been in our schooling even, something new, but it's like very simple to understand. Figure 2.18 is a heat map that uses data from the contingency table. Example we used previously to examine traffic accidents at several highway intersections. The darker shades indicate more accidents. So we'll say this, we'll take the same thing. We will take all the days of the week from that data. We'll see when and on this particular day, in which intersection, how many accidents have happened. You can see the data here. The darker one shows the accidents were very high on Monday in which street? Front street, correct?
Yeah.
So bigger frequency, the darker the table. That's it. And the least frequency, the lighter the table. It shows the intensity. That means where you have to act immediately, or what, like here definitely some kind of steps have to be taken to avoid, correct? Here still they have to work, but okay, that is not that dangerous. This street is not, this intersection is not that dangerous. Describe how to select among visualization types. So we are going to end this topic here today, and then we will enter into the mainstream topic, that is the measures of central tendency. Okay. Now,
Sure.
so given a variety of charts to choose from, it can be useful to have a framework for choosing which to use in specific circumstance. See, that we can see. And in general, we need to use the simplest chart that will clearly communicate the information to be presented. So don't make things much more complicated. See what happens when a cricket match is played. You see, they use histograms to show the highest number of runs. Okay. in overs, and they show the fall of wickets as well. So even a person who doesn't know statistics at all can also understand what the data is depicting, isn't it so? So they say use the easiest one, use the one which is very simply communicating the information. Now we may need a chart to illustrate a relationship between two or more variables. Okay, what they're saying, chart, isn't it so?
Yeah.
Compare two or more variables or show the distribution of a single variable. Typically the most effective chart types for these purposes are as follows: relationships, comparisons, distributions. Correct? So in relationship, scatter plots, scatter plot matrices, and heat maps. Correct? This category
Yeah.
comes under relationship, to show the relationship. Isn't it so?
Yeah.
For comparisons, bar charts, tree maps, heat maps. For comparisons among categories, line charts, dual scale line charts, and bubble line charts. Among the categories, that means men, women. They are working in the same industry, but we are showing the categories, correct?
Yes, sir.
And distribution, histogram, frequency polygons, cumulative distribution charts, numerical data, bar charts, tree maps, all come under distributions, everything. So this is what we have like discussed. Okay, now enter into the measures of central tendency, Abhijit.
Okay.
See, what is the measure of central tendency? Center means the middlemost area, correct?
Yeah.
So when you have a data set and they ask you to find out the average, your average would lie in the center. So
Agreed. Yeah.
to find out your average, there are three types of measures of central tendency. So the measures of central tendency, what we are discussing here about is mean, median, and mode. Whereby mean is sigma x by n, and it is represented by x bar. Median is, what is median? Median can be n by tooth, like it can be n plus 1 by tooth observation, correct?
Mm-hmm.
That means I'll tell you what like here which one is much more effective and which one is more trustworthy. Mode is nothing but the maximum frequency, okay, or
Mm.
the occurrence of something maximum number of times is mode.
Yeah.
So that's what I'm mentioning. Now let's discuss about mean. There are two things here: population mean and sample mean. Population, if I take India, if I take the entire India, the country here, okay, that can be a population. Am I right? If I want to find out average of something, isn't it so? If I
Mm-hmm.
want to find average of something, I have to take a data. So if I want to find out the average population of the entire states in India, so I have to take the entire India as my data, and the entire India as a data would be population.
Population.
And it is very tough to find out the mean of India. You cannot find out the population mean that easily, okay, by going from one house to another house, from each corner of the country to another corner. But when given the sample, you can easily find out the population mean, okay. So it
Yeah.
is easy to find out the population with sample, but it is not easy to find out the population mean directly. So if I take this India and I take one of the states out of this, let's say if I take let's say Telangana.
Yeah.
So this can be a sample, am I right?
Yeah.
So if I study the Telangana's population, I can easily find out the India's population in some way. So population mean is always represented by mu, and sample mean is always represented by x bar. The formulas are same, but the only the here we use different like letters. It's a Greek letter and it's a normal English letter. So can you just find out this one, Abhijit? I'm waiting.
Yeah. I think this is pretty simple.
Yeah, it's nothing to discuss. That's just a formality. Next one. Let's see the properties of mean. All interval and ratio data sets have an arithmetic mean. Okay, anything which is in the form of an interval or ratio data sets, you can easily find out arithmetic mean for that. All data values are considered and included in the arithmetic mean computation. A data set has only one arithmetic mean, not more than that, and it is unique. Okay, and you should always know sum of the deviations from mean is always equal to 0. Like, so for example, if I take some data 10, 20, 30, and the mean is 20, let's say. So if I take this and this is x, I take x minus x bar. Okay, my x bar is 20. Now deviations, 10 minus 20 is how much, Abhijit? Minus 10, correct?
Yeah.
20 minus 20 is 0, correct?
Yep.
30 minus 20 is 10, correct?
Yes. Yes.
So this x minus x bar, if I find out sigma x minus x bar of this, I get what? 0. Finished? Yeah, that's one of the properties. See, mean has a problem, actually, a serious problem. And the problem is mean gets distorted because of extreme observations. Fine.
True.
But what is that? Extreme observation. See, whenever you being an analyst, you may ask returns to someone, correct?
Agreed. Yeah.
And the returns what you should ask to someone is either you tell us median salary or you tell us the geometric mean. Because mean, arithmetic mean has a serious issue or problem. First of all, why I spoke about geometric mean is arithmetic mean does not take into consideration the compounding effect. If, see, arithmetic mean is only good, or it can give exact answer if all the data is same. That means if you have 10, 10, 10, 10, 10, okay, then the mean is correct.
Yeah.
But if the data is 10, minus 5, 20, minus 1, then in this case, if you find out a mean, if you these are the returns. These are the 5 years returns I'm putting in front of you. So I get an average return. But in this case, if I found out the average return, I will not get a clear answer. How I will not get a clear answer, Abhijit?
Because it might end up as a 0.
Why, like what is the problem? So I'm writing something here, just try to understand, okay? And I'll give you a good example also.
Yeah, please.
This chapter we can finish by tomorrow because it's a very big one. A lot of questions even in this. Now see here. See, if I speak about arithmetic mean versus geometric mean, okay? See, investment average returns, always I am putting a statement, investment average returns must be figured as a geometric mean, geometric average rather than geometric average to be accurate. Let's put it in this way. So whenever average returns of an investment you're considering, you should go for which average?
Geometry.
Yeah, because it takes into effect it properly takes into effect what? Compounding. Okay. It captures the compounding effect. Okay. So arithmetic mean will only be accurate. So this is very good when there is volatility. It is a good measure when there is volatility. Fine.
Yeah.
But mean, arithmetic mean is good when there is no volatility. which I told you when the returns are same, correct? That is 10% returns each period, correct or wrong?
Yeah.
Do you agree?
Yes, sir.
So suppose if I take 50% gain and a 50% loss. Okay. If I want to find out the arithmetic average, what will be the arithmetic average?
That will be a 0.
0.50 plus minus 0.50 whole divided by 2 is equal to 0. What do you think this is right?
No.
Why? So if I take 100 rupees and if I add this gain 50%, it becomes 150, correct?
Yes, again, yeah.
Again 50% losses, removing 50%, then I get 75. Okay.
Yes.
So how much is the loss for me? I'm in profits. I'm in break even. Here it shows break even. But did I break even? No, I'm in loss of
25 rupees.
25%. Correct.
Oh,
so geometric returns can give you a clear and accurate picture about this. So we'll find out that one and we'll prove it correct. Okay. So let's say you start with $100,000. That's the capital. Okay. End of year one, you have how much? $50,000. Let's say. So what is the return here? Minus 50%. Correct or wrong, Abhijit?
Agreed, yeah.
Now, beginning of year two, you have 50,000. Am I right?
Yes, you have 50,000.
And end of year two, you have again 100,000. Okay. So return is how much? 100%.
100%. Double the money.
Yeah. So when I take the arithmetic average of this, minus 50 plus 100 by 2 shows 25% returns. It shows or not? When I take the average of this returns, this and this, it shows 25%. But you started with 100,000. You still have 100,000. Did you make any returns? No. You made 0 returns. Am I right?
Agreed.
See, practically, you started with 100,000 and you still have 100,000. So what did you make?
Nothing.
But arithmetic average is showing what? Arithmetic mean.
That is showing 25%. Yeah.
Yeah, so that's the problem here. So we'll use geometric return because of this illusion, correct? So
yes.
Now see what geometric return will show you. So first geometric return formula 1 plus R1 plus 1 plus R2. It goes on 1 plus Rn whole power 1 by n minus 1. Okay. So now 1 minus 0.50. Do you agree? 50%? Hello.
Yes, sir. Yes, sir.
Yeah, it's into multiplication. Sorry. Into 1 plus 1 whole power 1 by 2 minus 1. So this is a 0.50. 0.50 into 2 is
1.
1. 1 power 1 by 2 is 1. 1 minus 1 is 0. Simple. This is correct or wrong? Correct.
Yeah. This is accurate. Yeah, I mean representative.
Yeah, we can believe this, correct?
Yeah, believable. Yeah.
Done. Okay, now let's go. So I said you mean is always like very much what we say is like impacted by extreme observation, correct?
Okay.
So like suppose if someone asks you how much package, if you want to go into a B school, you want to know the package of that B school, correct?
Yeah, yeah, definitely.
So that B school tells you our mean package is 30 lakhs. And then your father decides, fine, this is very good. My Abhijit is going to join this college and is going to get 30 lakhs. Very big amount, Abhijit, very rich guy. Now, the point here is, are they really getting a package of 30 lakhs? No. How? See, when we really inquired with the students, they said no, some like 4 lakhs, 5 lakhs, 6, 7. Okay, someone said this. Maximum they agreed for 8 lakhs. One guy got 1 crore salary in United States. So now you tell what to do. If you find out the average of this, what is going to be?
Yeah, it'll come out to 30 lakhs only.
Around, okay?
Yeah, yeah, around.
So, like 107, then 113, then like 118 and 122, 122 by 5. So 25s are 100, 25 fives are 125. So somewhere 25%, 25 lakhs, correct?
Yeah.
In that bracket. So this is the problem with mean. Okay, the mean gets distorted because of extreme observations. Now we'll take weighted mean into picture. What is this weighted average? We can try to find out the average. Am I right?
Yeah.
That weightage can be anything. For example, portfolio consists of 50% common stocks, 40% bonds, 10% cash. If the common stocks written on bonds, correct? Why? Because there are three portfolios here: stocks, bonds, and cash.
Okay.
Okay, and they have their returns even. Okay, so we can give weightage to those returns now. This one 12%, 7%, and 3%. When you have two things, just a second, Abhijit.
Yeah.
The weightage can be taken as, let's say, 100%. So I have how much stock? How much stock in this 100%?
50.
Hello,
50 half.
50. So that 50 shows the weightage of the common stocks in the total portfolio, correct or wrong? So the
Yes.
highest proportion, just a second. So this entire portfolio, what I'm considering, in that the highest proportion has been taken by what? Common stocks. So it has a weightage of 50% in the total portfolio. Bonds have a weightage of 40% in the total portfolio. Cash has a weightage of 10% in the total portfolio, and the returns, correct?
Yes.
So the formula is W1X1 plus W2X2 plus W3X3, and then so on. If you have more data, and then you get the weighted average. So the weighted like average here is 9.1%. That means this shows the return of this particular portfolio. Fine.
Yeah, fine.
Some revision for portfolio management, which we are yet to start. And median is a positional average. As I told you, you have to arrange the data in ascending or descending order, and then you have to pick the middlemost number. So this is what they have done in descending order, correct? The data they have made in descending order, and it shows the middlemost term is 23. So can I say that is the median?
Yes, you can. Yeah.
Yeah, this is odd number of observations. Okay, so in this we can take 5 plus 1 by 2th term and 6 by 2 third term. Okay, we got it. And if it is even number of observations, then 1, 2, 3, 4, 5, 6. So what we'll do? 6 plus 1 by 2 term, 7 by 2, 3.5. So 1, 2, 3, 4. So 3.5 lies between these two, correct?
Yeah.
So you can take 25 plus 23 by 2, average of that, since the observation lies between this. So you get 24. Okay. Any doubts?
No, sir.
And mode, already we have discussed the repeated ones. The one which is repeating maximum number of times is mode. Here in data, which one is repeating? 28. It repeated twice. This is the mode. Geometric mean already discussed, Abhijit. Just you can do this question. And after this, harmonic mean. So we'll take till geometric. Harmonic will continue from tomorrow. Okay.
Okay.
Okay, Abhijit. Please go through this.
Yes, sir. Yeah, understood. I solved it as well. Yeah.
Okay, Abhijit. So we will continue the harmonic mean tomorrow. I'm just calling you in 2 minutes.
Yeah.
Okay. Not much is left over. Harmonic mean and then skewness, correlation, those we are going to discuss. We can wind up that one tomorrow. I'm calling you. We'll discuss the time.